Hi, I'm excited to be here at the second national conference on low-carb medicine in Shenzhen, China. And since this is my first presentation to the Chinese people, I wanted to give a little personal story. I view Chinese Americans as disciplined, industrious, and ethical people that have contributed a lot to the American heritage and culture. I consider myself to be a globalist. This world belongs to all creatures. And that my country, the United States, is an amazingly diverse country which is multi-ethnic, multicultural, pluralistic society. And the strength of this country is because it respects people from all different and diverse backgrounds. So with that, I wanted to give an idea about cholesterol, its manufacturing or synthesis, how it is precisely regulated, to explain the mechanisms by which body regulates cholesterol. If we have an open mind and we don't consider cholesterol to be a metabolically bad molecule, we can understand the mechanisms and see what it is contributing for our health. And I have made this very simple so that even the person who is uninitiated in science will understand. I'm also going to explain that how blood cholesterol levels are discordant with cholesterol production in the body, and that high blood cholesterol levels often accompany situations which you would not suspect, such as fasting, such as being on a low-carb diet. On the contrary, blood cholesterol levels are somewhat low in people who are consuming a high carbohydrate diet, despite them being metabolically unhealthy, as I will explain. And I would like to resurrect high cholesterol and LDL, because 2/3 of cholesterol is LDL, because it has important biologic functions, especially in this pandemic, in terms of protecting us from bacterial and viral infections as well as inflammation. When an individual goes on a low-carb diet and starts fasting, and they get a blood work after a while, and with what they have done, they have lost weight, their blood pressure is better, they feel great, and yet when they get their blood work, they see a lot of red. The red is pointed out here. The LDL cholesterol is high, the total cholesterol is high, the particle number is high. All of this creates a panic, despite the fact that other aspects of this blood work are good, such as triglycerides are low, HDL is high, insulin level is low, inflammation markers are normal, and the LDL cholesterol is large and fluffy. If I were presenting this data, I would put all these numbers in green rather than in red. This is my attempt at explaining to you how our body regulates cholesterol. Cholesterol is principally regulated in the liver. This is a liver cell. And in the liver cell, if you focus on it, here is the nucleus, which is the captain of the cell. It gives instructions to the cell what to do. This is the endoplasmic reticulum. This is the cholesterol and protein manufacturing machinery of the cell. The HMG-CoA reductase is an enzyme critical for making cholesterol. So that is more or less the assembly line or the machinery that makes cholesterol. Our body has a cholesterol sensor in the liver cell. This is called SREBP2, this sensor is gauging how much cholesterol is there and whether the cell should jack up the machinery to make cholesterol or turn it down. In addition, the liver cell has something called LDL receptors, LDLr. These are receptors that are designed to pick up cholesterol from the bloodstream. Now, our bloodstream is watery. It is aqueous. It cannot carry cholesterol because cholesterol is a fatty substance. So in order to dissolve cholesterol in bloodstream, our body carries them in boats. And one of this boat out here is shown as the LDL particle. It has an outer coat that makes it dissolvable in blood, an identifying protein, and the cargo of this is cholesterol and triglycerides, in addition to other components that we shall see. And it is this LDL cholesterol that is picked up by the LDL receptor in the liver cell in certain situations. Now let us explore different situations. So this is a situation in which the individual is fasting. When you're fasting, the liver does not need to make any cholesterol. The reason is that in a fasted state, you're not growing, your insulin levels are low, cell growth is not happening. Consequently, the liver does not need to make cholesterol. The liver senses that. And since it senses that it doesn't need to make cholesterol, the cholesterol manufacturing machinery is turned down. The machinery that senses whether cholesterol should be made or no, which is out here, SREBP2, is also inactive. I will show you an active form of that a little bit later. Now, since the liver does not need any cholesterol, it either reduces the number of LDL receptors or puts the LDL receptors in hiding. And consequently, the liver is not picking up cholesterol from the bloodstream. What happens next? What happens next is that the liver is neither picking up the cholesterol nor making any, but it has some cholesterol and it starts exporting this cholesterol into the bloodstream as an LDL particle. I know this. I have looked at it in several of my patients, and there are very good investigations that prove that this to be the case. A fasted liver cell is not synthesizing cholesterol. It's not picking up cholesterol, but it is making LDL, which is a cholesterol-filled lipoprotein, a cholesterol-filled boat. And I think one of the reasons it's doing this, for people who are geeks, I have been accused of being a geek and a nerd, and I'm giving out a little bit of information for the fellow nerds, that perhaps the reason a fasted liver cell puts out an LDL is because in fasting there is autophagy. Autophagy is a situation in which senescent protein and cells are being removed, and consequently there is a lot of cholesterol flux. And this cholesterol needs to be transported back to the liver, and the LDL is a mechanism to do that. Now, this is an elegant study in normal people in which cholesterol was radio-labeled. Actually, the lipoprotein was radio-labeled in order to see whether a fasted liver is making LDL, which is the cholesterol-filled lipoprotein, or VLDL. And I'll take you to this slide and show you that in the fasted individual, the liver is making a lot more LDL and less VLDL. When these individuals are fed, the VLDL level increases or the production rate increases, the LDL production rate goes down. So to simplify this and make this redundant, with fasting, the body does not need new cholesterol. No new cells are being made. There is no growth, like no new muscle cells. And hence, the liver does not need to make any cholesterol, so it's not going to pick up the cholesterol from the LDL receptors. It's going to downregulate the LDL receptors. The sensor that tells the liver to make or not make cholesterol, which is SREBP, remains in the inactive form. I promise you that I'll show you the active form of that. The machinery that makes cholesterol, the HMG-CoA reductase, goes down, and the liver now exports LDL instead of VLDL, which is a cholesterol-filled lipoprotein. So thus with fasting, and again I'm making it redundant here, liver is not making cholesterol, it's not making the LDL receptor, the cholesterol sensor is inactive, it's exporting cholesterol as VLDL. What does the blood work look like? The blood work shows low insulin levels, low triglyceride levels, high HDL levels, and high LDL levels. Just think for a minute. If LDL was bad for us, then fasting would be very dangerous. Yet we know from several cultures, rich cultures, that fasting is one of the most health-promoting activities that we can have. And everybody agrees that low insulin, low triglycerides, and high HDL is a good thing. So, since fasting is good, is the paradigm that high LDL is bad for us wrong? And we should re-examine that. Moving on to a situation in which a person is consuming a low-carb, high-fat diet or an animal-sourced food diet, and I am putting slides side by side to indicate that both are nearly the same. So in this situation, the person is eating a lot of cholesterol in their food. And when they're eating a lot of cholesterol, the liver gets a lot of cholesterol into it from the outside. Since the amount of cholesterol is very high, the cholesterol sensor senses that there is enough cholesterol, I don't need to make cholesterol. And hence it turns down the cholesterol making machinery. Now it's picking up some cholesterol from the circulation, but since cholesterol is there in plentiful form, the receptor to pick up cholesterol is reduced. It's not numerous in number. Now, an individual on an animal-sourced food diet is very similar. A lot of cholesterol is present in the liver cell. The cholesterol sensor senses this, turns down the machinery to make cholesterol. The LDL receptor is not promoted to a big degree. In other words, there are not that many of them. You do pick up some LDL. However, the amount of LDL is high in the bloodstream. And since the liver has all this cholesterol, it's going to now not put out a fat-filled lipoprotein molecule. It's going to put out an LDL molecule. I will explain to you why it is not going to put out a fat-filled molecule in a little bit when we talk about fat synthesis. So with a low-carb, high-fat diet, the liver does not need to make cholesterol since we are eating plenty. There is growth. Protein initiates an insulin response. Many people think that protein does not initiate insulin, but it does. The LDL receptor is present but not numerous. the cholesterol sensing machinery is inactive. The cholesterol making machinery is turned down, and the liver is exporting cholesterol as LDL rather than the fat-filled VLDL. Now, this is to explain to you that when you look at the three macronutrients, or the two macronutrients in this case, carbohydrates and protein, protein initiates an insulin response. However, that insulin response is slightly lower in magnitude, and the peak is a little delayed compared to glucose as shown here in the green line. One of the best ways to induce a bang-up insulin response is to feed both protein and glucose together, as you can see here in this red line. To summarize, when you're on a low-carb diet, what does the blood work look like? The liver is not making cholesterol because it's getting enough from the outside. The LDL receptor is only slightly increased, not by much, because the liver already has a lot of cholesterol. The cholesterol sensor is inactive because there is plenty of cholesterol, and the liver is exporting a lot of LDL, which is the cholesterol-filled lipoprotein molecule. Consequently, what we see out here is that insulin is down, triglycerides are down, HDL is increased, perhaps more so than in the situation of fasting, and LDL goes up a lot. This situation is very similar to that of fasting. In fact, people on a low carbohydrate diet frequently fast because of satiety and lack of hunger. And if they don't, this should be promoted. Moving on to a vegan who takes no animal products and consequently they have no cholesterol in their diet. What is happening at the level of the liver? A liver cell is now depleted of external cholesterol. There is no cholesterol that it's getting from the outside. And hence, the liver says, hey, I don't have enough cholesterol. I need to make cholesterol. And now in this situation, what happens is that the cholesterol sensor gets activated. It moves from the ER, or in the cytoplasm, into the nucleus, and it tells, hey, let's jack up the machinery to make cholesterol, and the liver starts making cholesterol. Not only does it do that, but it jacks up the LDL receptors. It increases the LDL receptors so that it can absorb, it can take in the cholesterol from the LDL that's present in our bloodstream. Can this be shown in experimental fashion? Yes, it can be. So this is the cholesterol sensor, and in the panel to my left is cholesterol present in serum. These are cells that are grown in cholesterol-rich medium. And what we find out here is that the cholesterol sensor is not in the nucleus that gives signals to the cells to start making cholesterol manufacturing machinery. The signal is predominantly in the cytoplasm, as you can see from staining of the sensor, the SREBP2. It's messed up out here, I did not realize that. The sensor is predominantly in the cytoplasm when stained with an antibody. On the other hand, you take these same cells and you deplete cholesterol from their medium, the sensor becomes active. It goes to the nucleus and it tells, hey, I am depleted of cholesterol. I need cholesterol. Start making the machinery to produce more cholesterol. So to make it redundant, the vegan on a low cholesterol diet jacks up the machinery to make cholesterol, increases the LDL receptor so that it can absorb the cholesterol from the bloodstream. The SREBP2, the signal that is sensing cholesterol, moves to the nucleus, as you can see out here, and it's telling the cell, hey, make cholesterol. In summary, cholesterol is so precisely regulated and it is so important for our biology that if you don't eat cholesterol, the body will make its own cholesterol. Now let's explore how fat production or synthesis ties into the cholesterol production and synthesis and how it is regulated in the liver.